Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our deprogramming language series. In this lesson, we're going to continue talking about structs and unions. Now that we've covered them both, if you've been following this series, I want to talk about just some nice feature that you have here. And this is the idea of an anonymous union or an anonymous struct. And for those of you who've been watching this series for a long time, you might have noticed that we've looked at something quite similar to this, which is known as a variant. So we're going to go ahead, though, and look at anonymous structs, unions, see that this feature is available and why we may or may not want to use it. So with that said, let's go ahead and go to the dlanguage webpage here. We'll go to the language reference, down to structs and unions. And then on the right side here, you'll see highlighted structs and anonymous structs and unions. So let's go ahead and take a look at that. Now, the basic premise for this is that it's something that could be declared part of a class, a struct, or even a union without a name here. So you'll see in this particular example, I'll make it a little bit larger for you, that there's no name for this data type here. It is just the members here. So when we're actually accessing this struct S, you'll see we're accessing the members A here, and then we can just directly access B and C. Again, the symbol name is for us as programmers to make things convenient and sometimes provide extra information here. At the end of the day, when it's all assembly, it's all just numbers. Those symbols go away. So it would make sense that we could have some unnamed types or ways to sort of pack together data. And then again, remember that things like union versus struct determine, well, how this data is laid out. So with a union, remember that we have overlapping memory. So let me go ahead and just draw this struct here. Let's go ahead and take a look at it. So I'm going to draw this struct S, and we'll just go ahead and represent it as a box here. We've got room for int A here. So we'll always have 4 bytes in the deprogramming language. Again, a integer is well defined as 4 bytes. And then for this union, we've got a byte, which is 1 character, and a char, which is 1 character as well. So those two things will occupy this single space here. And actually, I should probably draw this. Let me draw this more to scale here, just so we don't get too confused here. Here we are. Something like that is a little bit better here. Int A, there we go, 4 bytes. And then for my union here, I've got just generically here 1 byte, which I can access as either a byte or a char here. Okay, it's going to take the maximum of those two types. If there was a bigger type in there, like say a float, then this would be as big as 4 bytes here. Okay, even if we only access it as a byte or a char here. Okay, so that's just a little review on structs versus union. But again, the convenience being that I can just access it as s dot B, and we know we're exactly talking about this piece of memory here. Okay, so that's the idea here. And I'll go ahead and show a few tricks where I think this is useful. And then we can do the opposite as well with a union here. So let's go ahead and just draw this data structure out that we see in the documentation. This is going to be the union U here. And this, again, is going to take the maximum type here. Okay, so it's either going to be an int, which is 4 bytes, or if I'm looking over here, the struct, which is, well, for an unsigned int, that's 4 bytes plus 1 byte for the bool here, and then it might pad it actually to, let's say, 8 bytes if it's aligning it here. In fact, let's actually do this example just so we can see exactly how the size of this here is. Union U and int A. And again, we did some examples, if you haven't seen on the series, with bit packing so that we could ensure it's exactly 5 bytes if we want. But let's go ahead and see here. So again, I'm omitting the name for the struct here, the bool here. And let's just go ahead and write out the size of for this particular data structure. And again, I would expect that this does get padded out. And it is indeed 8 bytes here. Okay, so even though we aren't using these. Okay, so that's the idea. Remember that a union takes its biggest member. So if we have a struct here that is, this many bytes large, if we're accessing B or C here, that means we're accessing this field here, which is 8 bytes. So even if we're just accessing here u.a, for instance, that's the idea. And again, we could see this. Let's go ahead and just do u.a. I think it's offset. It might be offset of here. Let's see if I can find that in the properties here. Offset of. Yes. offset of, I should have just guessed. Sometimes these things are pretty well named. And we can see that there's 0 offset there. And I would expect here, again, since this is a union, let's go ahead and see B here. The offset is, again, 0. And let's go ahead and try to access C here. And now this one has an offset of 4 bytes, because that's after the integer here. Okay, so just something to keep in mind, just a little nice review here. How unions work. Remember, overlapping memory here. Okay, so even if I'm accessing A and B, they're in sort of independent blocks of data, right? And a union only takes one block of data here, whether it's here or whether it's in this anonymous struct. Okay, so with that said, let's go ahead and get into a few examples of anonymous structs here. Okay, and I think we'll go ahead and start off with, let's have a struct here of, and I'm going to kind of copy this example here. Let's go ahead and name it something like a point or a vec3. This is a common one that you sometimes see in a library here. I don't know if this is the best example, but I think it's a pretty decent one of where I've seen it used here. And let's go ahead and do something like this here. Okay. And I'm going to actually make this a little bit bigger. We don't need the documentation as much for a little bit here. Okay, and let's go ahead and comment out a few of these examples. And what I want to show you here is I'm going to go ahead and create a vector here, vec3. I'm going to call it, color, something like that here. And let's go ahead and initialize it here. Remember, this is a struct. We don't have any constructors, so we can do the struct literal. I'm going to go ahead and put 255, 0, 0 here. I'm going to write out the color.x and the color.r here. Okay, let's go ahead and see if this runs here. And it says overlapping initialization of y here. Oops, let's see what I did here. Made a little error. And we'll amend this in a second here. So what was I trying to do? Oh, I have a union of, let's see here. I didn't quite get this right here. I want to do actually a struct here. And this will make sense once I tell you the goal here, but I think some people will see it here. And then I want to wrap this in an anonymous union here. Aha, okay, there we are. So let's go ahead and try this and stare at this piece of code for a little bit here. Now let's try to give this a run here. Now if I run it, it works. Okay. So what is the purpose of this example here? And we've got, and what sort of makes this feature neat of anonymous unions is I have these 2 unnamed values here. But remember what a union does, okay? It means that for its fields, which are here is one field, and here's the second field, I'm only getting one of these at a time here. Okay, so I can highlight, this block or, this block here. Okay, so let's go ahead and just draw this one out. This is a more interesting example for how we might use this. And I'll give some caveats as well. Struct vec3 here. Now, this union, if I look at its size, is going to contain an x, y, and a z element here. And then the one below it, the unnamed struct down here, contains R, G, and B. So same 3 floats for both of them, okay? Here we are. So either way, no matter what I'm doing here, I have 12 bytes, okay? And the difference is, there's sort of the overlapping memory. So on one side, I've got X, Y, and Z, which are each taking, 4 bytes each. Or I've got R, G, and B here. Okay, I'm going to draw a line between these just so we know that they're separate. Okay, it's still 12 bytes. But you can kind of see how what's neat about this pattern, and you'll occasionally see this in graphics programming. If I have a data structure like vec3, sometimes I just want one of those. And the trick here is that I can do access this with either X, Y, and Z. Okay, depending on if I'm working with like color data, the red, green, and the blue channel, which is common in graphics, or if I'm thinking about this more as a position, for instance, with X, Y, and Z. Okay, so that's something that we can do and you might see in folks' code. And that's just sort of for convenience, for context. to sort of follow this pattern. Now we do have other choices. For instance, if I want to create a new alias, I'll give you even a third option here. For instance, let's go ahead and put another struct here. And let's just put 3 floats here. Something like, I don't know, value, something like that here, right? Let me go ahead and run this. Whoops, I did it the C way. And sometimes I'm switching back and forth between languages. Okay, so there we go. Let's go ahead and see what the first field is. So color at 0. Okay. Whoops. Let's see, color dot value. There we are. Okay, so that's another convenience sort of function that we can do here. So you might occasionally see that. Now, depending on what your schools of thoughts are, you may like this sort of pattern. Depending on what platforms, I mean, you sort of have to make sure that you're careful with how this data gets packed together and ensure that it is 12 bytes. This is the great thing about D, where you could do some sort of compile time check here. Like a static if, to actually see like that all these fields are, and we haven't talked about static if yet, but this is for my D programmers who are advanced and maybe shouting. You might want to actually look at what the size of this union is, what the offsets are of each field, and make sure that they overlap if you want to be, super safe here, right? And you could put that in a unit test block, which we'll also get to. But anyways, this is just one of the ideas of what you could do with a struct and these anonymous unions here. That's kind of neat. We don't want to forget our other tools too. If you just don't like this pattern, for instance, the other thing you can do, and I'm going to just rename this. I'm just going to call this 0.3 or something. With same X, Y, and Z. Some folks instead will say, we should just create an alias and call it, color equals 0.3 alias, position equals 0.3. That's another way to sort of give context for how you access these things. And then maybe you would just have like the value or override the brackets operator, the index operator, and just access things that way. Okay, so a bunch of different options for how we can do things. Okay, so these are just a few examples. So I'm just going to put this in a comment here. So alternative school of thought, some folks may like this solution better than the above. Okay. So, a couple different ways to think about things here. But let's keep talking about anonymous unions and structs. There's still yet more things we can do. And basically what I'm going to show you next is, and I have this ready on the D webpage. So again, you can go to documentation, library reference. Let's actually just do it here. And if I scroll down, if I can just search variant here, standard variant, which we've looked at, this is what's known as a tagged union. And basically, this is probably better than the pattern that I'm going to show you, right? Because it's implemented. It's a little bit more type safe. But, if you want to implement this yourself, or if you're just limiting yourself, for instance, if you don't want to use the standard library, so let me put that here. If you don't want to use the standard library, Phobos, you could sort of implement your own tagged unions. So what does this exactly mean here? Well, let's say that we have some data structure here. I'm just going to call it like a tree or something. And maybe more specific, you'd have like a binary tree or something. And you want to sort of keep track of the type here of things that this tree can hold. And I would actually, again, this is a great chance to review some of the things we've done in D. Maybe we have some enum for nodes or something. And I'm just gonna say node A, node B, something like that. So let's improve this here, nodes. So we have some type here. And then basically we use the same trick here where we have, what is the node that we can actually store. We only need to store one of them. Usually when you have a tree, it's of the same type of nodes here. And I'm either gonna have a node A, I don't know, I'll just call it N, or N1, or, we could just label this as A, or we could label this as B here, something like that here. Let me run this. Oops, I've got to actually declare these types here. Let's create a struct, node A, and another struct, node B, just so we have these different types available and it compiles. And again, basically what this is doing, or how you'd use this, is you'd sort of say, okay, I need to, when I initialize this tree, I need to pick what this is going to be, right, from this enum. And then based off of that, you access in your code if this is a type of whatever in your functions, right? You'd have your member functions like get node or whatever, or the root, access things. And this is sort of how I could imagine folks implementing some sort of polymorphic behavior. I mean, this is effectively the types of tricks that you could do. Again, if you're restricted to C or better C, again, you can look at that feature that's part of a D language, how to do this. So again, this is just another use case of where you might see anonymous unions. The last use case I could kind of think of, because I wanted to give some more practical use cases, and let's go ahead and look at another one here, is usually something like a event. Maybe we have something like this, and I'm just kind of making this one up on the fly here, but we might have, again, same sort of pattern here where we have the type, and then we might have a bunch of fields here. So let's go ahead and say, how do I want to do this? I think I'm going to use the same struct here, anonymous struct here. So we always have an event, and then it'll be big enough to hold, like, what happened, okay, in an event-driven system. Like you click a mouse, you move a joystick or something. So let's just go ahead and do that sort of thing. Key up, key down, and then we'll have, I don't know, joystick moved, something like that here, okay? Let's actually model that. I don't know, maybe it'll have a float for how much you move the joystick. And maybe some other fields here. Joystick up. Actually, realistically, let's use the right types. We would probably just have booleans for these. Again, always good to be precise here. Up, down, left, and right. Okay. Let's make sure that compiles. Compiles fine here. I actually want to split this window here. Let's just go ahead and hold this struct in our view. And let's do a little bit of vim here to shrink this window a little bit. There we are. I just want to make sure you have the whole data structure in your view here. There it is. So just keep that in mind. And let's actually see how we use this here. Oops, there we are. Let's go down to our main. And let's say, again, if you have some event that's going on here, let's just capture it. Event we'll call E. E type equals, I don't know, 7. And again, you might better structure this with an enum, again, just so you can have an enumeration of all the different types that are available, like moving, pressing a key, maybe something with a joystick. Again, something more realistic might be just event type 0. And then you would say e.keyUp equals 1 or something like that. Okay. So let's just go ahead and run this just so you can see how it runs here. And again, the nice use case that we get here with the anonymous structs and unions, where we don't have to write out all the different things here. And again, it's just sort of a compact use case. I would probably, again, just more recommendations, label these keyboard, joystick, etc. Okay, so that's just a few different use cases that you have. Alrighty, folks, so with that said, I'll go ahead and let's go ahead and do a brief recap here. Let's close this down. So we've talked about anonymous unions and structs here in our documentation. Let's go to that here. Anonymous. Oh, it's category 9, wherever that is. There we are. Which is a nice feature to have. Again, if you're coming from a C or C++ background, this should be pretty familiar. I think in C, I'll have to double check, but it might be a C11 feature. So you might need a newer compiler for that. But it is available, it is useful, but we do have implementations like of std.variant, which we've seen, which are tagged a little bit more type safe. Again, I'd recommend probably building something up like this, but if you need to avoid the standard library, you can use it yourself. All right, folks, and then we looked at some little tricks we can use. Some folks have used tricks like this, where it just makes it more convenient based off of the context that you want to access something. Sometimes that's a nice way to do things. And otherwise, you might want to implement something like this, just which is basically getting towards or moving towards almost like a polymorphic behavior here, which can be neat. And then this is where I've seen it again. And in these use cases, these are in like C code bases, but anyways, you know that it's available there. All right, so if you enjoyed that, again, check out or track your progress on my webpage here so you can follow along with the lessons. And otherwise, hope you enjoyed that. Looking forward to more videos that'll be here in the future. And let me know if you have another use case for anonymous unions or structs that you really, really like. I'd be curious to hear what else you folks come up with. But with that said, folks, thanks for your time and attention as always, and I'll see you in the next one.